Investigate and explain that when a force is applied to an object but it does not move, it is because another opposing force is being applied by something in the environment so that the forces are balanced. Observe the effect of temperature on a chemical change. Cooking. In this investigation, we're looking at physical changes, and we're looking specifically at how temperature changes water between liquid and gas and back and forth. And that process is called evaporation and condensation. And in this particular model, we're also going to include precipitation. I have a container. Any container that holds water is called a reservoir. So I have a container which is going to model a reservoir. And for this model, this container is modeling an ocean, the Atlantic Ocean or the Gulf of Mexico. You choose. I'm going to put a glass container, which is empty. Both of these containers are empty, by the way. I'm going to add a glass container to my model, and I'm going to place that right in the middle. And you're going to see the purpose of that in just a few minutes. Now, the next piece that I want to add is some land. So I'm going to use this piece of limestone. It's actually fossilized coral. Take a look at that. Well, fossilized coral there. And we'll place that over there, and we're going to model that, and that will be our model of the land. Now all we need to do is add water to our model. So I'm going to pour water into the model, and I'm making sure that I keep the water out of this container. Perfect. Everything fit in there just perfectly. Here's our coral island. Here's our glass container, which is empty. It's dry. There's nothing in there. And here's our model reservoir, the ocean. Now the next step that we're going to do is we're going to cover that entire container with some plastic wrap. But we're going to cover that with some plastic wrap. And I'm creating a model of the entire water cycle by doing this. Now I'm going to put some tape around the edges just to hold the plastic wrap on. Tape it pretty good there. Make sure that plastic wrap's not going anywhere. Okay, so I've got a container, has water inside of it, an empty container for water to collect, our coral island. We have some plastic wrap on top to model the atmosphere, and I'm going to add this last piece, which is just a metal sphere, and I'm going to place that right in the middle, just like that. What I predict will happen is that when I add a heat source to this model, the water inside is going to heat up, the water will evaporate, it'll fill the container, it's going to condense on the plastic wrap surface here, and as it condenses and more water condenses, those droplets of water are going to move to the center because that's where we put that metal sphere. You can use a rock for that. I happen to have a metal sphere. You could use a marble, a rock, stack of coins, whatever. You just need something in the middle to weight that down. That causes everything to flow towards the center. So we should have a functioning model of the water cycle: evaporation, condensation, and precipitation. If we come back in 24 hours and there's water inside that empty cup, we have a functioning model of the water cycle. So originally I thought I would let the water cycle model run for about 24 hours, but it was going so well that I actually let it go for 48 hours. You can see when I tap the surface of the plastic wrap that on the inside
There's droplets of water that are condensing together, and you can't see it here in the video, but they're actually falling down into the glass cup, the empty glass cup that we put inside the model. When we open up the plastic wrap, of course, all that water's dripping on the inside. It evaporated from the main tub, condensed on the surface, rolled down the surface, and dripped into the glass container. And here you can see we've got clean, fresh water that's precipitated or dripped into the glass container. We can measure that using a graduated cylinder. Use a funnel so I don't spill any. And we have 20 milliliters of water that evaporated, condensed, and precipitated in our water cycle model.